So I hope everyone had a good weekend. Welcome back to class for remote learning week 2. So here we go. Let's get through these logarithms so we can get moving and maybe get into some trig here. So we're going to be solving some simple exponential and logarithmic equations, solving more complicated exponential and logarithmic equations, and we are not going to be using the last one here. So we can take that off of there. For two basic strategies, we either want to get them to 1-to-1 or use the inverse properties. And we'll look at those properties down here. So as long as you have the same bases, then you can set your exponents equal to each other. And the same with logarithms, as long as you have the same base, you can set what's inside equal. So the first one, I don't know, we would have like 2 to the x equals 2 to the 4th. So in this case, x would equal 4. So you want to try to get into the same bases. Same with logarithms. If you have log, you're going to have y, x equals y. Then our inverse properties, which we have here, and we're going to deal with those coming up. So here's some examples, and you can go through these on your own. But 2 to the x equals 32. If you know that 32 is 2 to the 5th, well, then all you need to do is set the x equal to y, or x equal to the other one, and you get x equals 5. So you set your exponents equal. Here they added ln 3 to both sides, and now we got x equals 3. C, somehow we forgot the first part of this. I don't know what happened to that. Must have got deleted out of there somehow. That's probably 3 to the negative. That would be 3 to the negative x. I'm not going to write that in there. And we know that 9 is 3 squared, so you get negative x equals 2. So x equals negative 2 by dividing by, it says by negative 1. Here we're going to use the inverse property, where we're going to take the exponential and use natural log because it's an e. And natural log of e to the x equals ln 7. That x comes out front. So your next step would be x ln e equals ln of 7. And ln needs 1, so that gives us x times 1, which is x, equals ln 7. And you can do different things, So we'll come back to these when we get a chance. That's pretty much all we're going to need for those anyway. All right, so basically what I want us to do is look at these and say, okay, could we solve them? And if we solve them, are these approximations or are they real answers? So in the first one, when we're solving it, there's not much I can do. I can divide by 3. And I'm going to end up with e to the x minus 1 equals 20. Not much I can do with that. So I'm going to change it to an exponential form because it's an e. I'm going to use a natural log, which ln base e is just ln of 20 equals x minus 1. That's a minus. And you can use your handy dandy calculator and find out that ln 20 is 2.996 after you round it 3 decimal places, remember, equals x minus 1. So we add 1 to both sides, and we get x equals 3.996. And if you check both of those, you're not anywhere close to that. They're both in the 2s. So they're not either. Coming over here, we're going to change this to exponential form. We're going to make it e to the 7.2 equals 4x plus 5. Subtract 5. And I get e to the 7.2 minus 5 equals 4x, and divide by 4. And I can see that I have an answer right here. Right, x equals 7. So this is exact. But if you take this and put it in your calculator, you end up getting b with a rounded off answer. So this is approximate. Approximate. Again, stuff we're not going to do, but I wanted you to take a look at. Did I start this? All right, so moving on. So here's some strategies we're going to work on. Rewrite the original equation in the form that allows you to use a one-to-one property of exponents or logarithms. That would be the easiest one if you can do it that way. That would be the easiest one for you to solve. Rewrite the exponential equations as logarithmics and solve them, or write logarithms as exponentials and solve them. So moving down, first one we look at, there's a couple different ways to solve this one. I'm going to attack it by the method of, I know that if I have 4 squared, that equals 16. So I'm going to replace and get 4x equals 4 squared. Now that I have my bases exact same, x equals 2, and that was that easy. You could solve that by changing it to a logarithmic function, and then using change the base formula, but this is so much easier this way. The other way would be log base 4 of 16 equals x, which means you're going to have x equals log 16 over log 4. And when you do that in your calculator, you're going to get 2, which you got over here. Going back on number 2, I'm going to need to get those together first, that properties that we used last week. So we're going to do the natural log of x over 2 equals 0. Now, change it to exponential form. E is our base to the 0 equals x over 2. Well, e to the 0 is 1. So 1 equals x over 2. Take both sides times 2. Oh, that don't want that to happen. Okay, where are we at here? All right, I'm back. Not sure what I brought up there, but it'll run on its own. So we get x equals 2. Down here, we're going to make, let me move this down. So we're going to make this be e to the negative 1 equals x. Well, e to the negative 1, when I stick in the calculator, I get 0.368 equals x. Over on this one, I'm going to change the exponential. 4 to the third equals x. And 4 to the third, I believe, is 64. Yep. All right, we're back. So, next page, more notes on logarithms. We're going to look at changing from logarithmic form to exponential form to see if it helps us solve these problems. Now I'm going to stop and make this thing a little bit bigger. So it makes it easier for me to actually write in here and try to solve these things. So solving them. In we go. Log base 5 of x equals 2 is 5 squared equals x. So 25 is x. We have 8 to the 4/3 power equals x. That's a matter of sticking it in the calculator. And I believe you got to end up with 16, but let me check here real quick. 8 raised to the 4/3 and a 16. Hopefully these videos are helping. Moving down. Again, we've got our base is x on this one. So x to the 3rd power equals 81. I'm not sure that one helped us a whole lot by changing that. What can we raise to the 3rd power to get 81? If you know it is 3. So that's pretty much the only way I can think to solve these right now. 3 to the 3rd. No. 3 to the 4th. So what raised to the 3rd power equals 81? Well, let's see. I guess we can always take the cube root of each side, because that's what we've done before. Or x to the 3 equals 81. And we take that, raise that to the 1/3 power, the reciprocal, if you remember doing this before. And 81 raised to the 1/3 power. Yeah, doesn't come out too well. So I'm just going to, well, we can round that off. X is going to equal, somebody's just going to have to round off. 4.327. Over here, x squared equals 10. So, again, like up here, you could have left it x equals the cube root of 81. Probably how I'd left it. If it wants a round off answer, you can do that. On this side, we're going to, it's squared, so we take the square root of both sides. X is going to equal the square root of 10. And again, we could round that off. Here we've got a 2 to the 3rd equals x minus 4. Well, 2 to the 3rd is 8. So 8 equals x minus 4. And we add 4. And we get 12 equals x. Slide this one in a little bit. And 8 to the 2/3 equals 4x minus 3. And 8 to the 2/3 is going to be 4. 3. 7 equals 4x divided by 4. And x equals 7/4. Not 9, that's a 7. All right. So we're going to look for one-to-one properties in the next ones. And what do we have here? We got a log base 6 and a log base 6. So that's simply x equals 9. And on to the next page. We got base 2 and base 2. So we end up with, oops, I need to get that pen. 3x equals, I'm going to go ahead and distribute this. 5x minus 2. If I subtract my 5x, I get negative 2x equals 2 divided by negative 2, and x equals negative 1. Down here, the base 4s, 5x minus 4 equals 3x. And subtract the 3, well, I'm going to subtract it this way. Negative 4 equals negative 2x divided by negative 2, and I get 2 equals x. Again, just basic solving if you can get the bases the same. So 3x equals x squared minus 4. Well, now this is a little bit different. Subtract that, and you get 0 equals x squared minus 3x minus 4. Two factors of 4 that when I subtract them, I get a 3. 0 equals x minus 4 and x plus 1. So I end up with x equaling 4 or negative 1. And that's our old solution set. We could have used solution sets all along for these. So sometimes you have to use your quadratics and your quadratic properties and your factoring skills. If you can't factor, remember, stick them in the quadratic formula. We did that. There's a nice long one. X squared minus 3x minus 19 equals x plus 4. Get it equal to 0 because it's a quadratic. X squared minus 4x minus 23 equals 0. That's negative 19 minus 4. And this one doesn't factor. So I'm going to have to go with my quadratic formula. X equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And this is just crazy. So I'm just going to punch it in the calculator, see what I get here. And I'm going to get negative 4 squared minus 4 times a, which is 1, times c, negative 23. And the 108 underneath there. I do the square root of 108. I get 6 root 3. So I end up with that x equals 4 plus or minus 6 root 3 over 2 So x is going to equal 2 plus or minus 3 root 3. So go with what I'm saying, not with what you're saying, because this is hard to write with. So we're back looking at some of these to solve. We write 8 as a power of 2. Okay, fine. That's 2 to the third. Write 64 as a power of 4. That's 4 to the third. Right. 1,296. I'll do 6 times 6. Six times 6 times 6 times 6 times 6. Well, if I did 6 to the fourth, that would equal that. And over here, I can write 9 as power of 3 because I know that 3 squared is 9. Then I can have 3 times 2 parentheses x plus 1 gives it a power of 3. Then distribute that, and you get 3 to 2x plus 2. And that's how we can write that. So we're going to look at solving these by trying to figure them out. So here we go. And there's different ways to do these. Like I said, you can rewrite them as logarithms always and see if you can come up with it that way. First one's pretty easy. 3 to the x equals 3 squared, so x equals 2. The next one, I know that 2 to the fourth is 16, but that would give me 1 over 2 to the fourth. But if I make it 2 to the x equals 2 to the negative 4, then x equals negative 4. Down here we're straight up. 2x equals x plus 1, subtract the x, and x equals 1. I'm going to make that 25 be 2 or 5 squared. So I have bases of 5, and I get 3x plus 2 equals 2. And when I subtract 2 and divide by 3, I get x equals 0. This one becomes an interesting one. When I get 3 to the x equals 3 to the 2 times x minus 1. I get x equals 2x minus 2. Subtract and I get negative x equals negative 2. So x equals 2. And that 1 over 16 is a base 2. And again, you're going to have to go to a base 2 on these. So really what I'm going to have here is base 2 to the negative 4 times 2 minus 3x equals base 2 times 5 times x plus 4. Now I have my base 2's, and I multiply that in, and I get negative 8 minus 12x equals 5x plus 20. And the rest of it is just solving it. Yeah, add 12x to both sides, subtract 20 from both sides. What do I get there? I get negative 28 equals what? 17x divided by 17. X equals 28, negative 28 over 17. Again, just solving them. You can also use your properties to bring them together. So because I have a base 6, this is going to be log 6, base 6 of x times x minus 9 equals 2. I'm going to finish this problem, and then that'll be it for the day. And we'll work on the rest of these come tomorrow. So we've got log base 6, so 6 squared equals, multiply that in, x squared minus 9x. Well, it looks like we got a quadratic. So we have to deal with a quadratic. So x squared minus 9x minus 36 equals 0. And I need two factors of 36. That whenever I subtract them, I get a 9. That would be negative 12 and positive 3. So x minus 12, x plus 3 equals 0. So x equals 12 and x equals negative 3. Now the problem is we need to get back up and check these. Here's the deal with these things. You never have a negative inside of an exponent or inside of a logarithm. If I put negative 3 in there, or even in here, it's going to give me a negative. So that one gets canceled out. And my final solution is just 12. And like I said, we'll come back to these tomorrow. So thank you very much. Good luck on the worksheets, and we'll see you tomorrow.